All right, so we're going to continue our discussion how to solve this optimization problem for a refinery factory. So we talked about the constraints. We talked about the objective function, which is basically optimizing the net profit for the company. We had two tables here, one on the fraction of the products for each fraction of the components actually for each product. I have 4 products here. And then we also have a table for the cost and gain for each product, for each component actually, a component of the products. Okay, so we talked about these two constraints. That this one says that the number of barrels should be less than the minimum asked by the customers. Okay, if customers want 38,000 barrels a day, we have to generate less than that, because if we generate more than that, we may not be able to sell all of them. Okay, so just to refresh your mind, let's look at the third constraint here. This says 25% of X1 product. Let's see, 25% of right here. So we look at the third row here. 25% of product 1 is aviation fuel. 15% of product 2 is aviation fuel. 25% of product 3 is still aviation fuel, and 15% of product 4 is aviation fuel as well. So with that, I can go ahead and write the third constraint, saying that 25% of X1 plus 15% of X2, 25% of X3, and 50% of X4, all of that would be the aviation fuel, which should be less than 30,000 barrels a day. Note that these X1 to X4, these are in terms of 1,000 barrels a day. So the 1,000 is hidden in here. And because of that, we don't multiply anything by 1,000. So this is 30,000, this is X1, and 1,000 barrels a day, and so forth. Okay? All right, so we can also write the fourth constraint in the same manner. 4 constraints here. What other constraints we're looking at? Well, these are implied. I said in this class, we always imply that all of the variables are positive. So this is the non-negativity constraints. Okay, so we have one set here, one here, and also this is the availability constraint, which is given in this table, right? So product 1 should be less than 20,000 barrels a day, product 2 less than 25, and so forth, right? And we're saying here the same thing. So like product 1 should be less than 20,000, product 2 should be less than 25,000, and product 4 should be less than 30,000 barrels a day. Okay, so this is another constraint, and here's the objective function. So let's put all of them in a spreadsheet. Here's the spreadsheet. I'm going to move it over here. Problems go to the left. We're going to do side-by-side comparison. First, 4 variables, x1, x2, x3, x4. These are the headers. I'm going to start with the guess value. Let's say 1, 1, 1, 1. I don't know, just make a guess. Okay? So let's look at the constraints. An objective function. So let's maybe start with the objective function. Objective function is going to be this cell. So this is, let me make it bold. All the bolds are header or comment, which means spreadsheet doesn't care. Okay? Alright, so the objective function is going to be 5850 times x1, right? So it's going to be 5850 times a2, because my a2 is going to be x1. b2 is going to be x2, c2 is going to be x3, and d2 is going to be x4. So this function is written all in terms of the cells which we know from before. So a spreadsheet is all about referencing the different cells. The coefficients are calculated already here. So this is the 5850. This is 5050. Well, we have to multiply this by 1,000, which I have already there. And then the coefficients times the variable, the corresponding variable, right? like blue times green, like this one times x1, the second one times x2, the third one times x3, and then the fourth one times x4 times 1000, add them up, that's the objective function. And that's exactly this line right here. All right, constraints, left-hand side, right-hand side. So let's look at the first constraint left-hand side. That is this constraint. So 15% of x1 all the way to 25% of x4, and that's what I have here, all in terms of the cell references made. This is going to be x1, x2, x3, x4. Okay, so that's the first constraint. You can go ahead and write the other three. So you have the other three constraints up to here. Okay, so this is basically the demand constraints. Then we have the availability constraints, which means x1 less than, x1 less than 20 and so forth. So then I write the right-hand side, the left-hand side. The left-hand side is x1, which means just cell A2. The second constraint is x2 less than 25. x2, the left-hand side, is going to be just b2 and so forth. And the last one is going to be d2, right? So that's x4 less than 30. So d2 less than 30. And here's the right-hand side. Well, I also put the right-hand side because I forget. I mean, there are a lot of constraints here. Writing the right-hand side is not necessary, but I just put them in here just to make sure that I know what those are. And then when I go to that window, I can just look it up and just manually put them into the solver function or solver window. Okay, so we're all set on setting all these coefficients. I think we can go ahead and put them into the solver. So I'm going to go to data, solver, and then I'm going to put one by one. First, which one is the objective function? My objective function is this cell, which is B14. So here's B14. I want to maximize over what variables? My variables are sitting here from A2 to D2. So here's A2 colon D2. And the constraints I added, I just read it up to you. You can just go ahead and add if you want. So the first one I add, maybe I can delete the last one and add it for you so you see what I mean. So let me delete this constraint and I add it so you see how we can do this. So I'm going to add the last constraint. So the last constraint says this guy should be less than that guy. So which cell? This cell, less than or equal to constraint. I think I can reference this as well. So you can just either say less than 30 or you can just type it 30. So I'm going to type 30. Both work. Okay? If you don't want that, then you can just clear everything and then just click on that cell. And then OK. So it's going to put that, well, it went up, but this is going to be down here. Yes, I think this is this. Right, so A13 should be less than B13. It's this constraint. I have it already, so it looks like it's duplicated. Let me just delete one of them. Let's see, 6, 7. Okay, so I'm missing this one, so let's add this guy as well. So I have to add the other one that I just deleted, I think. There's one missing here, which is this should be less than or equal to that. So I'm going to put add, and then this cell should be less than or equal to this cell. Okay. Add. Oh, sorry. After you add, you can cancel. So then it's, yeah, so the last one is also added. Okay. I have 4 constraint for demand and 4 constraint for availability. So here's the availability. Here's the demand constraint, and then non-negativity comes from this option. Just say yes, all of the variables are non-negative. I'm going to use simplex method, and I think we're good to go. Just hit solve, and there you go. So it found the solution. You're going to keep the solver solutions, yes, and then here's the solution. It should be 15,000 barrels of product 1, 25,000 barrels product 2, 30.8 thousand barrels of product 3, and then 0 product 4, which is interesting. That means there's no That's weird, but I think, let me just check. Yeah, yeah, that's right. The solution is 0. Interesting. That means no product 4 is needed. Okay, so this is it. And then the maximum profit we get is about $370,000 a day is the profit. Huge, right? So that's how much these companies are making these days. Okay, so I think this is how you can solve any linear programming using a spreadsheet. We talked about example 8.1 and 8.2. The next one is 9.3, which is now nonlinear programming. So in nonlinear programming, we have objective functions and constraints, both of which are nonlinear. Now this time we can have multiplicative or multiplication of two variables like x1 times x2 or x1 to the second power and so forth. So for nonlinear programming, we cannot use simplex method. Simplex method is only for linear optimization problems. Okay, so stay tuned for next section on how to solve optimization problems using a spreadsheet. We're going to talk about particularly nonlinear programming section 9.3 of the textbook. So stay tuned and thanks for watching.